Hello? Is this thing on? Oh god, hopefully that wasn't horrible. Oh god. I can hear myself. Looks like we're live. Hello, everybody. Hello, hello. Let's get this out of here. Wink. Hello, everybody. Check out the Discord if you are not here already. There are announcements every time I go live, which I'm going to write right now. I am live at twitch.tv/Lensor. And I also have a YouTube channel at LenSR. No underscore, sadly. They don't allow underscores in the URL. But I do have a channel URL on YouTube now, so that's fun. What are we doing today? It's a mixed bag. Let's just go. Let's do that. And then we'll do, yeah, at notice. See, I'm good at this. I'm good at this, I swear. How's everybody doing? There's no white line today. I fixed that, so hopefully that's better. Sorry, says, yep. What's going on, Sarade? How's it going? It is so great to see you. You know what I just realized? I didn't even write welcome. You guys were not welcomed properly. There we go. Oh, I can't even get it right. There we go. That's good enough. How's everybody doing? How's everybody doing? I think, therefore I am. No, I think I should just get right into it. I have no clue what I'm doing today. So let's do it. Let's just open up LensorOS. Make sure we have like the latest changes. I'm pretty sure we do. I think we just press F to fetch upstream. Okay, there we go. We just press F. Fetch from upstream. Yeah, we got the latest updates. We're good. We're golden. Nice. Yes. I have already looked at some things. That's right. I don't need this. I was looking at the to-do. This is LensorOS. It's available here. Link in the description if you're on YouTube. And we're going to try and write a network driver because, you know, why not? Let's just, you know what I mean? Let's search for E1000. Invocation. We want to figure out, let's make sure I did this right. Because I copied it. The follow to show how Nick. So here we have it running QEMU system x86-64 with a NIC, which is a network interface card, as far as I know. That's exactly what we would like. And E1000 is actually something I've seen mentioned here, I feel like. Yeah, see, so, okay, what does it say? If you're using a GoTo, is the Intel E1000 and has thorough coverage. See Intel. Okay. Perfect. All these links will be in the description. If anybody in chat would like a link to these pages, let me know. I'll paste them in there. And basically, yeah, we're just gonna start writing some network stuff. Why not? Let's make sure that everything works because I did change the boot to include that thing. So let's just go boot it up. Nice. Look, I've already done it. We can make this a little bigger. Oh, I don't know what buttons I'm pressing. That was crazy. Why? What is this warning? We're supposed to cast this to an integer or something. Makes integer from pointer to a U size. Uint putter T? Probably a uint putter T. Okay, it does still boot up. It does still work. And we can do... Oh, okay. here, we really got to update the... Hey! So we just used Xaish, I should say, to run echo with an argument wow. You couldn't see me typing it, but I typed it, as you can see. And it actually outputs wow. How amazing. So it says, so basically, I'm assuming our starting point is just Ethernet frames. We'll see. I don't know. I think we're just going to try and get the MAC address. That's like going to be our first thing. Let's make sure it booted with the... Can we see the command? We don't see the command QEMU did. Failed to load boot because they're not on there. Starting EFI internal shell runs the startup.nsh. Found bootloader on FS1. Okay, so we look to be going well in the boot process. I don't see any network card specific problems being spit out. I don't see QEMU complaining any more than it normally does. So we should be good. So yeah, basically, we're nowhere and we got to get somewhere. So the only key is to start. So I think the thing would be, do we want this to be, I don't think we want this necessarily to be like a file. Do we want these to be files like device? Because it's not really going to work like that. I think it should just be like its own thing. Because if we look in K-Stage 1, we're going to have to do something in K-Stage 1 to initialize this card. Otherwise, it's not going to ever work, right? So somewhere here, we have to initialize network stuff. Probably after... Do we need... If we have etc. hosts, if we are copying Linux, it should probably do after the VFS. Perfect. After the VFS, before the scheduler. Sword says, files are just the user level interface. At least the Linux kernel actually has a struct socket. Yeah, I don't know. So basically, if I copy the standing convention for making a thing in LensorOS that needs a driver, let's look at the pit, because why not? Hey, look, all the definitions and comments. What do you know? Yeah, that's probably important. VMe says, hello there, Scarborough Joy. What a nice emote. Okay. So if we take a look at the pit, it's basically just a class. And this class effectively just has, it doesn't inherit from anything. It's kind of just standalone, has its own API, its own everything. I feel like this is kind of the way to go. Vimi says, how are you? Thanks for asking. I'm doing okay. I'm doing okay. I am making it through. How about you, Vimi? Thank you so much for tuning in. So I don't know if a network driver, if it would be worth it right now. I think that would be a bit premature. So let's just write a network driver kind of in this sense. And then if we want to in the future, we can implement like a base class network driver and then have like read write or have like Ethernet driver be a base class. But I don't even know where that's at right now. So we're just going to start. Is this E1000? I think that's the standard that we're following, the Intel E1000. That's at least the model we have. So let's look at, it says that the E1000 has great coverage on OS Dev on this page. So I think we're just going to go here and start here. So it says, yeah, just a single driver is fine, I'd say. So I think we're just going to start with E1000.h. We'll do C++. Ooh, what happened there? It's, hello? Okay, there we go. If and def. LensorOS, I don't remember how I did this. LensorOS E1000. Whoa. Header. Sure. Ah, there's an underscore I missed. Okay. This thing. Beautiful stuff. I should really just make an Emacs command that inserts that. Or like Control C len or something. Yeah, so now we just have to start. Pretty sure it's pretty classic to include integers so that we can use u32, usize, uint, stuff like that instead of craziness. I think that's good. That's good. The actual standard is IEEE 802.3, at least for Ethernet. Yes, that's probably like the what the card adheres to. Okay, so we're gonna have a class E1000. I think we have to start with one of those, and then a class starts out private, so then we can do public down here. And let's think about the hidden data that we will need for this class, the privatized. IEEE is usually pronounced IEEE. That's funny. I had to count how many E's I already said. I was in there. Vimy says insert my copyright in the vim :first command. It's meta x insert my copyright. Come on. So this is interesting. This person is just writing this to learn how to get it working on hardware. Okay, I don't need to know that. This wiki does not utilize all the features. Beautiful. That's what I'm great at. Like the AHCI implementation utilizes like a tenth of the actual AHCI capabilities. But hey, we can read and write files now, so suck it. We have 8086, which is a vendor ID. So it looks like we have a bunch of defines, buffer sizes, transmit commands. I have gathered those. I don't know if he means those or those, but it'll be fine. We'll figure out if it's wrong. Now let's define the data structures for the TX and RX buffers. And then he did so he says transmit and receive and then does receive and transmit. You gotta love logic. So what is num RX descriptor? So this is the amount of these descriptors. These are volatile. Why would you not just mark the struct as volatile? This is confusing. Can you not mark a packed struct as volatile or something ridiculous like that? Yeah, so basically it looks like we have a descriptor in MMIO or something. Hardware will write this. The E1000 will write to this, which is why it's volatile, which tells the compiler, hey, this can change even when we didn't change it in our code. And there's 32 of these descriptors somewhere. And then there's 8 of these transmit descriptors. Are these identical? So this is 8, 10, 11, 12, 13, 14, 16 bytes. I'm pretty sure they're the same then. 8, 10, 12, 13, 14, 16. So they're both 16 bytes. There's 32 and 8 of them respectively. Okay. So it says they're not identical. They're not identical in their members, but they are identical in size. I should have been more specific. You're correct. They're very different because when we're transmitting, we need to say, hey, this is the command we're transmitting instead of the checksum and stuff like that. I am curious what CSO and CSS stands for. I don't actually know. We'll figure it out. Volatile read writes, okay. And then we have just port IO. We can do that. I'm pretty sure we already have that, so we're good. Hey, look, Classy 1000, and they do inherit from network driver in their implementation, apparently. How the gears move. Okay, Jesus. We have some PCI stuff. It looks like IO base and mem base. Okay, so this is more PCI stuff. So a PCI function, which is what we're going to call this network card, because PCI function is like an implementation of something. So this PCI function or whatever, there's a way where in PCI there's a, oh man, this is going to be fun. Right here, here's what I'm talking about. So if you don't know, the PCI is like somewhere in memory that houses a bunch of data about the hardware, and there's PCI devices that can talk through this implementation, and it's very useful. And it's found in the MCFG header, and basically we find the PCI address, the PCI bus, through the MCFG header. So we get this device configuration, we get the address of it in MMIO basically, and then we just enumerate this PCI bus, and there's usually like some amount of them. Saraid says, RX has a checksum, TX doesn't. Nullputter exec says, hello, Lens. Awesome, hello. Thank you so much for tuning in. Starbaz47, hello. What's going on? What's good? So when we enumerate this bus, it's basically just enumerating the devices, the 32 devices on the bus, and then you enumerate the device to enumerate functions, each of which has 8 functions. You can see how there's lots of like levels to this. And finally, once you get to functions, that's when it starts to get fun, because you can actually get stuff is implemented. It's not just a table to hold more stuff. And basically, we finally find currently, let's do this. Can we do this? We'll see if this breaks. It's probably not going to compile. Okay, it did compile. Normally, some of this stuff changes by the time we re-enable it. Nullputter exec says, I am not a system programmer, but we were programming hardware stuff today. USB/etc. Yeah, that you could say that. We're doing a network stack. So we're going to try and get the MAC address of the system out of the network interface card, the NIC. Well, it still ran. And if we look at our debug output, we should have a hefty amount. Yes, a hefty amount of stuff, as you can see. So you can see we have a function at this address in MMIO, and it's an Intel 82G33, G31, P35, P31 Express DRAM controller. It's a bridge device, host bridge, and then we don't know what the progif means. Nullputter exec, do you intend to have a GUI? For this OS, there is a GUI. It's not expansive, but there is absolutely a GUI already running in user space. Part of why I'm setting up this network stuff is so that we can get sockets as files, and then we can set up clients and servers locally. But yeah, you can see this, what I'm typing in here. This is a GUI running in the frame buffer, graphical frame buffer in user space. We got PWD, we got echo. We don't got a lot, but we got some bits. We can fork and exec. We have another shell we can run. You can't see me typing yet, but that's just an implementation detail. You can see we can run wow and a echo wow and a child shell. Vimy says, but do you have awk? As soon as you port it. Honestly, you could probably compile awk for LensorOS at this point. We have reading files. We can't necessarily write we can't write new files. We can't open and write. Vimy says I might. That'd be awesome. Or what would be better is if you can roll your own awk implementation instead of writing a port. Middle Cloud, hi, how's it going, Middle Cloud? Thank you so much for tuning in. Sarbaz47 says, I've tried OS Dev multiple times, but debugging QEMU with GDB is always my rage quit point. I mean, at multiple times I've been doing exactly that and going, this isn't going to help. And I just am there for 2 hours stepping through things and going, this doesn't make any sense. How do we get here? But most of the time I have a better time doing like debug printouts. But yeah, as you can see, we can print out this stuff, and do we actually find, look at this. We actually find some sort of network controller, and it's an Ethernet controller. We don't know the progif or the ID, so I wonder if we can figure out this ID. Let me see if I can open something over here. What am I looking for? What are we talking about? I was looking for an ID, PCI. I'm searching my notes if I have anything. I don't, so PCI ID. Can we do here? Not there. Here. Okay, I think I found it. Yeah, this looks like it. It's not ideal, but it'll be fine. So here we have what is effectively, what do we get in the Discord? Okay, very nice. I'll have to read that. Can I mark as unread? Okay, thank you. Vimy says, my own implementation. Seriously, dude? I finished my 8 hours of work, then migrated my mail server, and I have 24-hour hackathon tomorrow. A big choice is implementing awk from 0 or sleeping. I only encouraged you to. I didn't say you had to. Oh, that's hilarious. We should have printed out the numbers instead of unknown, but it's fine. Can I just look up E1000? Is that gonna... I looked up E100, but I don't think I got Intel. I don't see 8086 in this, so I don't know. We must just not have it, or I'm looking up the wrong ID. What do we have? 0, 1, oh, I wonder if it's, well, that's interesting. That is interesting. Okay, that didn't work out. Either way, it doesn't matter. We don't necessarily need the device name for it to work. So what is the progif of, I need to go to the PCI page, I'm sure. See also? What do we got? I'm not seeing specifics. I can't even remember where I found all those. So here we go. Network controller. Ethernet controller. And it has none progifs. Okay, so that's probably why I don't have any progifs. So we have a network Ethernet controller. I guess we just take this and run with it. Can I look up E1000 PCI progif? Well, I don't need a driver. README text files. Yeah, no thanks. Can you send me to some documentation maybe? No documentation, huh? Adapter user guide. That's not a dev. Dev guide. Okay. Well, we're just gonna go ahead and just assume. That always goes really well. Do we know what class it's in? I don't think we do. The class is... Why do we have two classes here? There should be subclass. Just gonna mention that. What do we got? Oh man. Vimy says, give me my Red Bull! Middle Cloud, not too much. I'm tired after a fight with my boss. Oof. Which he thinks he still knows programming after 15 years of not touching any programming language. Vimy says algorithms really didn't change much unless you consider lattice encryption. It's true. You can know programming for a long time. It's not like he's going to know specifics, but you can know the gist of how to do things. So why are we checking this directly? I feel like we should have a bit of a way to, you know, not use the number. Do I not? I don't have definitions. I did it this way, which is an interesting way to do things. Jesus Christ. Yeah, so we standard print the thing if we don't know what it is. Well, in that case, we know we have E1000 in network byte order. So it appears that maybe that's the progif. So when we print unknown ID, where do we print? I guess I need to go network controller, Ethernet controller. That's unknown subclass. Okay, now where's... That's it. Okay, that would make sense then why this isn't working. So as far as I know, progif is basically... If you don't know, I know I'm not explaining things very well. This is how PCI is kind of laid out. So in order to reuse subclass and not have it get too big, they have class codes. So there's classes, subclasses, and then within these subclasses, there's something called the progif. This basically tells you the exact specifics of what it is. So I am just seeing if we are printing out this or what. Also, I feel like we should be printing out new lines here. You know what I mean? It feels a little silly to not be printing new lines here. Maybe it's on purpose? Because if we return unknown ID, you would think that it would print out the thing and then unknown ID. But we're actually getting the vendor name as part of a bunch of things, so we end up printing them all here. We could return... I mean, that's not a const... Interesting. I wonder, can we do this? We can't do this at compile time. Well, continue the standard. Comments. We have a network controller. What's our subclass? An Ethernet controller, which is 0. Whoops. So if our subclass is equal to 0, and we don't really have a progif as far as I know. So one thing I am gonna do, I'm gonna go to get progif, and then I'm gonna do a query replace for standard print this thing. And I want to replace it with sort of that, but I'm going to say unknown, just a regular message, you know what I mean? Not insane. Unknown progif, blah, blah, blah. And then that, I feel like, will help a lot. So let's replace this. I should really just make a function at this point. This, or a macro, which returns unknown progif and does exactly this. This. Let's try that. Middle Cloud says, by the way, Lenser, have a coffee or what drink of choice you prefer from me. Thank you so much. I appreciate that. Don't tell me you're oh, Middle Cloud. He's going crazy. Oh no. Thank you so much, Middle Cloud. Did you hear the cacophony of notifications? Shout out to Middle Cloud. Thank you so much. We got a $10 donation. What a champ. 1080, as in 1080p. What a legend. S you and your A's, don't wear a C, and J all over your B's. Thank you so much, Middle Cloud. What a champion, supporting the channel, helping us go further with this. With our silly little hobby OS. What are we doing? We're just checking the output. Does it work? It did work much better. So we have unknown progif bleh. And then so that's not 1000E. So where are we getting unknown ID? That's probably the only other place it could be. So this is good. So in the vendor ID should be 86. And our 100E. Can I do PCI lookup? Is that here? Is there a link here, I mean? Maybe here? Okay. Well, this is interesting. What am I looking at here? Naturally. Okay. Where are we at? Oh, that's a little big. Intel has made a lot of stuff. Oh, it was 100E. That's right, not E100. I could just search for it. Okay. Pog. Subsystems. Is that the progif? I don't know what that is. Where's the subsystem? Okay, I'm not going to worry about that. I'm going to worry about this. Okay, what do we have? Let's just do this one specifically. I don't think any of these others. Is this the same? 82540 EM, 82540. Okay. Not going to worry about it. I'm just going to say this is the one we got. This is what I'm going to return. Beautiful stuff. And now hopefully we can know this a little bit better. Oh yeah, Middle Cloud, the I'll probably buy myself a tea. Maybe a box of tea. Because I like tea a lot. It's nice to have it. Softface says, I'm building Gen 2, wish me luck. Oh god, good luck. Yeah, let us know how that goes. Blaze it, mask. What are we doing? Show me the money. Ha ha ha. Yes, we did it. Okay, so now we know this is this thing. And we can detect that. What are we detecting? This is the ID, device ID. What would this be? this thing. Then we're going to say device ID equals 100E. I didn't do that right. 100E equals E1000 network card. Sure. PCI device. Oh, what happened there? Then we can do, we're going to create a device. Devices E1000, which is a reinterpret cast of the PCI header 0, pointer, PCI device header. Okay. Yep, I'm great at that, I swear. Okay, so we need a system device. That's something as well I didn't think about. C++. Thank you. This is print. So basically, when we create a device, we're using a system device API. So the devices.h, we end up with 3 devices here. I see. So we can kind of store our own data depending on which device this is. And then I'm sure the device, when created, has these numbers. Yeah, so sysdev, major, storage, minor, blah. So up at the top, we're going to have a system device number now for, I guess 2 was already here. Well, we're going to make that 3 then. And we're going to go 2. And this is going to be network device. Sure, why not? So it says, all right, I'm back. Where are we at? We are basically still at the beginning. We're slowly implementing the network part of the system devices. So we have network controller. Sure. And then we'll say we don't have a network driver. But we'll say to do network driver at data 1 or whatever. Cool. And then from here, we're going to have just the one 0, which is going to be yeah, we're going to have just the 1 0, which is going to be the E1000 network controller. Sure. Sure. Okay, so now we can update this. These should probably be static const expr, shouldn't they? Am I wrong there? Are they? Is it okay because they're globals? Network equals 2. Network device major numbers. Yeah, we'll make this a little simpler. Network device. And then we can have a network device driver at data 1 or whatever. Cool. Sysdev major network, storage, network device flags, and network device minor numbers. We have no flags. That seems a little wordy. I think E1000 is fine. Cool. So it says inline const expr. So it says inline const expr for global vars, static const expr for local vars. Okay. Oh, I did not do that right. Space, please. Thank you. Okay. So now we have major network, blah, blah, blah. And we can hopefully go to devices.h and define E1000 as a system device. And this may want to be E1000 device. We're just going to do that for now. And as far as we know, we're going to have a MAC address. What size is a MAC address? I don't even know. It's probably important to know. Is it 14 bytes? It's 6 bytes. Okay. A buffer for storing the MAC. The MAC address. Okay, so it's 6 bytes. We're just going to use 8 bytes for funsies. We can probably get away with 6 by doing this. Sure. MAC address. And we're not going to know it when we create the device. So maybe this doesn't need to be even go here. Maybe we don't need anything. We can kind of just have it be empty for now. That's fine. And then we just need to define the constructor, as far as I know. How the system devices thing works. The MAC is not 8? I don't know, it says 6. I don't think it's 8. Networking doesn't really have multiples of 8 that often. It's kind of sad. Devices, E1000, device. Very good. Thank you, very cool. None of that stuff. Yeah, don't even do that. Technically, we probably don't even need this, but I'm gonna leave it here. Why are you mad? Missing specification no accept. Do I have to do this? Did I screw that up? I did screw that up. What did... Oh, man. You still mad? Hey, we get another ban. Pull out the ban hammer. So it says IPv6 is 8. 8 16-bit fields, that is. I was going to say, I was like, that doesn't sound right. So it says yeet. Middle Cloud says, thanks, Arade. Yes, yes. Null Putter exec says, did I miss a ban hammer move? Possibly, possibly. So this is looking good now. We should be able to create this from PCI. So this, we should probably pass in the device header. Do we not do that? We're gonna need the device header. I'm kind of spooked out that I guess for the HCI controller we need that. What do we need for this card? And base. We need the base address and the type of bar 0. So bar 0 is exactly this thing. So we should probably just maybe we don't even need to do this. So from the bar, let's leave that for the actual E1000 itself. And then yeah. We're gonna do something like this, I think. And then this is going to be header. Just like that. This is a mess. Sure. Okay, and then in PCI, we're going to need to actually pass that, which we do. Okie doke. So now in case stage 1, after we do all this PCI gunk, you can see that one thing we do is we loop over the system devices and do HCI controllers, HCI ports, and then GPT partitions. So we're basically just going to do another loop over these system devices. And we're going to say if device major is equal to sysdev major network, that's right. And dev minor, I think I did this wrong for LensorOS. Dev minor is equal to sysdev minor U1000. Middle Cloud says, no Nightbot? Nope, no Nightbot. I can just probably do this as well. Perfect. Hopefully that's working. And with this, we should just be able to print out detected E1000 network card. Probably should have put like more new lines or made it more obvious. When is this going to happen? After the pit and before opening. Okay, so it's going to be quite early. Quite early. I love that I typed clear in chat. Oh, I'm such a boomer. Oh, we had a triple fault. Fantastic. It's irrecoverable. Yep. Wonderful. What have I done? We printed out the GPT partitions. Apparently I did something very bad here. It's just a U16 device ID. This is a device header. We're saying if class, subclass, reinterpret cast, we just create another device, which is an E1000 device, which takes in a PCI header 0 pointer. Apparently I've done something wrong. So we have the class, subclass, device ID. So can I print something out saying creating device at blah? And then just do a void pointer for PCI device header? Are you going to be mad at me for that? You're not going to be mad at me for that. Why did we, what happened? We just triple faulted and then crashed. GPT partition. That's not ideal. It did the same thing. What have I done? Ah, that would definitely screw things up. It's treating it, the PCI device, the network, as if it was as if it was a storage device. That's not an HCI port, to be specific. That's not going to go well. Oh, God. Okay. We still triple faulted. We did create the device, though, so that's pog. Why do we triple fault now? So major network, minor E1000, header. We create the device, we get through all that now, and we get to treating it as if what? Are we not checking major? We say if dev major is equal to sysdev major storage, and search does not equal 0. So if the search flag is set, if minor is equal to GPT partition or HCI port, do things to it. And is this where we're failing? After unique ID, so if I go to system, AHCI controller is 0. So are we somehow doing this wrong still? What did I do? Sysdev major network is 2. System major storage is 1. E1000 is 0. So is it somehow, I mean, we're checking the major everywhere we are. When we create a system device from a major and a minor, we set major to major and minor to minor. We have a storage device driver possibility as well. Set flag, get flag, flags, major, minor, return minor. Ban hammer. This is fun. Sorry, yeet. Reloaded. So we do sysdev network. I don't know. What could possibly be going wrong? So we say if dev major, blah, blah, blah. Then we're inside here and we say if, else if minor. And it's saying GPT partition. And we're finding a valid one, which is interesting. This is the actual, I think, the EFI system partition, if I'm not mistaken. And this is our LensorOS data partition. So it's kind of curious that this isn't working. I'm not sure what isn't working. I'm sure it's silly. But I don't know what. Major, minor, flag. So can I just print out all of these? Is there a way to just print system devices? Let's just do that. Let's see the whole system printed out. Player Anonymous, Addictive EQ, thank you so much for the follows. I appreciate it so much. Can't believe we're at 376. It's incredible. Another triple fault. Beautiful. We have 2 system devices at that time. And it's 2.0 and 1.0. So we appear to have the network controller just fine. But then we're triple faulting just out of nowhere, which is kind of annoying because it just means a random fault is happening. Middle cloud, what is the purpose for this? Bots to post in technical stream, which we know what to do with the message. Yeah, I don't know. No one ever, I'm sure they have a 1% hit rate and that's enough for them to keep it going or something. Doo-doo-doo-doom. So we create new system devices here. Which is a GPT partition. Major storage, major storage, major storage, major network. Okay, just checking. So it's not in here. Where's the actual place where we are failing? It's the K-stage 1 bit, right? Storage device. Okay, what storage device are we looking at for file systems? Because partition, like we shouldn't get here if we're not on an actual device that has file systems on it, but we're just triple faulting right away. So we have two devices, 1.10, 1.0, 1.1. So we're not looking for anything there. 1.10, as far as I know, is the file system. GPT partition, yep, there we go. Okie doke. What have I done? E1000, I didn't touch anything else. Detected E1000 network card. Subclass 6 instead of class, that's a comment. Standard print. Else if. Then we create a device. I added a new case and it now prints longer stuff, I guess. That should be fine. Network device, inline const expr. Another one, dang, I've noticed there's a lot of spam activity. It says null putter exec. Middle Cloud says maybe they think if they send messages, we'll have a success rate on bans. Lamau. They could be using this as a testing ground for ban rules or trying out their bots in the wild. True. Well, I didn't expect to run into an issue just adding the device to the system. This is kind of annoying. I don't know what's going on then. So why? We have two partitions. Clearly. We have two valid file systems, but the fat file system is failing. It's triple faulting in try create or whatever. Did not find fat fs. All right. Another triple fault. Wonderful. Did I not put that under an else? Ah, that's funny. Well, we don't get there nonetheless, so we know it's here. I don't see anything crazy going on. Oh, whoops. Maybe. So I don't see anything crazy going on. So what's going on in try create then? I can't believe I'm gonna have to hunt this down. Not driver, return null putter. In which case we'll fall through and continue. Okay. So what is driver? Why do we, let's just make sure that we actually have something sensible. We're gonna have partition and driver. Alrighty. We'll get there one day. I'm not sure what could be going wrong, to be honest, because I don't think we're getting here. I think it could be a heap thing. I don't even know. Invalid cast to void pointer from shared putter. Wait. So we have a shared putter, which is partition. Do I need to do that? Probably like that. No, yeah. Okay. Because we just need to get the raw pointer from the shared putter. Or not. It's just complaining about the next one now. But it still says request remember get in partition, which is of a pointer type. So we're actually doing dev.get here. So this, why is it complaining about a shared putter then? What? Is this a pointer to a shared putter? What did I just run? Okay, I ran the wrong thing. Don't mind me. There's no member name get. Okay, just checking. Just checking. This is a little confusing then. I guess we don't print out the partition. Lots of triple faults. Okay, so we have a driver which looks to be on the heap. Which is just so interesting. I'm very confused as to why this isn't working, because I'm not 100% convinced of what's going wrong. We just get a triple fault at some point, apparently. Well, there's only a certain amount of ways to do things. Do we see 1? Do we see 2? Do we see 3? How bad, what bad are we doing? Size of BR. Well, we still triple fault, so that's fun. We get to here 1 and then triple fault, so it's not here 2. Okay, so are we in here too? We can move here 3 up. Okay, so it's probably in driver read raw, especially if driver's not a driver. So it says, I mean, you can try commenting out parts of the new code and see what it is that's causing the triple fault. Is the driver null? It's not null. We printed it out here. It was something on the heap, the kernel heap. We still just see here 1 and then triple fault. So we're getting a problem here. I'm presuming right in here. Hopefully we see here 1 here too. Molly the Man, thank you so much for the follow. And first time chat. What's up, Molly the Man? Is it Molly or Molly? So it says, is it trying to create a fat from the NIC, or am I interpreting this incorrectly? It's not trying to create a fat from the NIC, as far as we know. It's just trying to create a fat from an actual GPT partition. We find 2 partitions, and then it's just, okay, we got to hear 3. Both times. Interesting. Okay, so this is just in try create for the port, the partition, and then we triple fault on this EFI system partition. We triple fault in driver read raw. Driver. Is this how that works? BR. Sure. Mr. 6 asks, is this C++ 23? Yeah, pretty much. We have standard print. Middle Cloud says, you said that the purpose is to play Doom. Why network card? Why not? The purpose, that's not the purpose. That's just one goal. There's no singular purpose. That's a stack address for sure in the kernel. In the higher half. This is a heap, kernel heap driver at AC4. Just like life. Exactly. You got it. Mr. 6, thank you so much for the follow. I think only MSVC standard lib implements it as of currently. Yeah, pretty much. Aren't you assuming things? Okay, what? Aren't you assuming things on that GPT GUID partition table, some sort of hard-coded value? What? I'm not sure what you're on about. So it works until it doesn't work, which is interesting. It's very interesting. What do we go on to do later? Is there a static? There's no static. We just make a static pointer cast of a shared. FS this equals. We move the driver. Okay, that's interesting. So we move the driver and BR. We don't have the same driver twice in a row. The boot record's in the same spot because it's the same stack frame every time. And we're not keeping. What's it mean when we move the boot record? What is this file allocation table driver? It's an R value reference. And we move it into BR. Which is a boot record. So that should be fine. Well, I think we're going to take the surrayed. Middle Cloud says, do you think you will add QEMU? I don't know what that means. What did I do? So what if I just don't create the new device? I'm pretty sure this will make it work. Obviously, the network card won't work. All the way at the end. Would you look at that? It worked. As you can see, we just found 2 valid FATs. Nothing went wrong. Everything was fine. Can we print something out when we get here? Does that really screw things up? Middle Cloud says virtualization. I'm still not sure what you're on about. I'm using QEMU here to run the OS as if it was on hardware. I don't know how I would add it. Well, that still worked. We'll just get our printout up here. Found you in the nowhere. Okay, so let's do this then. Found HCI 1.0 SATA controller at That's Brainsman says, "Heyo lads, how's it going, Brainsman?" Another reason why I'm doing this instead of anything else is because the compiler, I gotta classify struct in sys5 and then have to figure out how to return aggregate values from functions. And I'm just so done dealing with that right now. It's just not even something I want to do. Brainsman says, I believe he's talking about adding virtualization inside your OS, but that doesn't really make sense in this context. I would agree. If you want to run QEMU in LensorOS, we're a long ways off. Brainsman says, I'm fine. Glad to hear it. Glad to hear it. So we find a controller at Bufau, and we find a network controller at Bulu. So everything's looking fine here. It's just when we add, so is it somehow, when we add a system device, is that what's broken? What do we have devices as? Devices is a vector of shared putter of system devices. Oh Christ. Molly the man, did you make the kernel from scratch? Yep. Mr. Mugame, where can I watch porn on it? Wherever you normally do, I guess. Once we get this networking up and running. You are free to use the system how you want. Molly the Man says that's cool. Thank you. I appreciate that. I've had help with the C++ stuff with Sarade. He wrote the C++ standard library implementation from scratch. We push back the move of D. So we use make shared. And then we push back a system device of a shared putter. Shouldn't this be this? Am I crazy? So it says that's layer 7. We're currently on layer 2, so yeah. Moldy the Man says, sorry, good job. Brainsman, oh neat, you have your own standard lib. Yep, that's how we have standard print running in the kernel, for example. Invalid static cast from pointer to not, huh? So make shared isn't return. Am I crazy? So don't we need to make a shared putter to push to this? Isn't it doing that implicitly? That's not how static pointer cast works. I'm not a professional. If dev major equals major and dev minor equals minor, return dev for auto devices. This just returns the first device. That's kind of a mess. So it says you fix that now. Well, that's how it was, but it just doesn't seem right. Why are we making a shared putter and then casting that to a regular system device? It just seems odd. Isn't this kind of a weird cast from a shared putter? So it says, no, this is right. Okay. Then what's going wrong? Because this is the issue. Or it's the device that we're pushing, which is the issue, but I don't think that's it. Triple fault. Wonderful. Calling read raw and driver at blah. We need size of BR and BR. Void pointer driver. Brainsman, I need to get my modern C++ foo up a notch. I don't use constexpr and R-value refs as much as I should, and I can't play with all the cool new standard lib stuff on embedded. I mean, you can, you just gotta write it yourself. We have a vector of shared putter A, but we want to create a shared putter B. We can't store shared putter B and shared putter A first. That's what static pointer cast does. It's just... So static pointer cast is casting to a pointer of system device. But it's casting a shared putter of B into a shared putter of into just a regular putter of A, and then it's creating a shared putter from that. Just sounds messy. What driver? This should be the GPT partition device driver. Calling read raw. Not sure what just happened. Byte count. Buffer this. I guess I could just do driver. Static pointer cast A, shared putter B creates a shared putter A that holds the same putter as the shared putter B, but as an A. Messy. Is the return type variadic? Doesn't look like it with a hint. No, return types can't be variadic. And also, what function do you mean? That's a good question. Another triple fault. GPT partition driver, read raw. So we're getting all the way here. And hey, we figured it out. We found it, boys. We found the null dereference in the kernel. GPT partition driver dot get. When are we creating the GPT partition driver? So we create an AHCI controller. I don't know what I'm doing. So we're looking at a port, and the only way that we actually create a driver is if we read from this port and get a GPT entry, in which case we say, hey, device. Do I need to standard move device? I might need to standard move device, don't I? It's a reference to a system device. It's a reference to a shared putter to a system device. I don't think there's any way we're creating a bad one here. Like, I'm not quite understanding. GPT partition driver. Null. So we say if we should ignore the partition, if we null GUID, if we have a known GUID, if we... I'm not certain. Is GPT present port driver get? Does this need to be dev.get or something? Why is this not working? We make a shared putter. I don't know. Why would it be null? The only thing I can think of is if this is getting cleaned up somehow. Because this scope exits and then it goes away. And we're getting garbage or reusing or... Not quite. It's so odd. Harumph. So if we're not, okay, so we should be able to print out the driver that we're feeding it here, right? So it says static pointer cast increments the ref count. Okay. Brainsman says, no, I was talking about the C++ 17 feature where the compiler can template a function without using what? Having the function return type as auto. Expected primary. Oh, I didn't put a comma. Intercept is getting to me. Intercept is looking good. I didn't talk about that, but we have references now. So that's POG. Which means we can do binary, not binary, but just operator overloading very soon. Didn't mean to do that. Hey, if you're watching this, be sure you're staying hydrated. Drink some water. Oh God. What went on? Still getting null. Well, that would be an issue. You know what I mean? If you try and create... What the fuck? How is this null? Am I insane? I feel like I might be insane. I don't know what's going on anymore. I don't know what's going on anymore, dog. Is that not working? Is it trying to copy the underlying header? It's just a pointer. It's just a pointer, no? We have a pointer to header. Much like up here. Do I need to do this? Is that really the difference? If that's the difference between up here and down here, I'm going to be very confused. Straight says header works as expected. Well, we'll see. I'm just curious. Are we somehow creating one with null? Okay, that didn't help at all. Good to know. So that functions as expected, which means we shouldn't have to do any of this. What? How are we getting null? Okay, where are we getting null? Okay, stage 1. How is this null? Star 8. I don't get it. I don't get it. Do I have to do like if not dev here? I just don't get it. Null system device. at I mean, I don't think it should ever be null. That's kind of weird. That's what I'm saying. It's a reference. Is your iterator broken for, what is this? Is this a vector? In that case, it's not broken. It's a vector. So iterator's fine. We iterate vectors all over the place. We're good. Why and where are we creating a null device? I don't know. We're not. This is we have two things. Here and here. That's it. I don't know how we're creating a null device. It's kind of trash. I guess we don't even have a minor. We just have blah. Null system device at blah. But that's going to be null. Isn't it? What? I want to, like, make a little macro that does this. Maybe just V. I don't know. Okay, another triple fault, so that's fantastic. Still null. Creating GPT partition with HCI port driver. Huh. Null system device. So we're creating... Can't you hook a GDB instance into QEMU to better find these null putter derefs? I mean, I don't think it's going to help us at this point. It's not easier. We can spend 20 minutes doing that and going, yep, that's where it's going wrong. Still don't know why. That's my experience with debuggers. The way comes, okay, let's talk about C++. So we get null system device at blah, but only after we create a null system device at blah, which is down here. Dev. Port is equal to dev.get. Searching HCI port blah for a GPT. We found a GPT. We get two partitions, and one of the partitions gets a null driver somehow. Little sus. So port is not null because the GPT is present. So then we say for each partition, do things, get the partition. So right, is this moving dev device? We don't want to move device, we want to copy device. That's what this does, right? Because if this moves device, then the next time we come around, it's 0. It just kind of doesn't make sense. Like, this is our loop. We're not doing anything crazy in here. So how is device becoming null when device isn't being... You know what I mean? Isn't being assigned to? Is really one question I would have. Well, dev is the loop variable. It's not. This is a for loop. I is the loop variable, if you want to use that terminology. This is a for loop. once around the for loop and twice around the for loop. It's suddenly becoming null inside the inner loop. Yep, you got it. Here's device. Using static pointer cast. Does this move? We need a copy. Do we need to do this? For the last time, that's not a move. Well, then why is everything acting like, oh, it's a move? How's this becoming null? Because we're not assigning to it. So unless you can give me an answer, stop telling me it's not that for the last time. Well, what's an alternative then? If the device isn't being moved in this loop, how else would it become null? If you don't have an answer, you can't really complain about me keep asking the same thing. Like, well, this is all I can think of. So how does make shared work? I don't even remember. So when we create an HCI port device, is this fine? I don't feel like this is fine. I'm forgetting something for sure. Print the value before and after the make shared. Okay. You mean before this, the static pointer cast, the thing that was there before, right? Eyes moment. Brainsman says epic OS dev drama. Is it? I'm just trying to figure this out. Doesn't make any sense. So we have... If make shared static pointer cast is somehow zeroing out an L value parameter, then something is going horribly wrong and not here. Yeah. Null. Null before, null after. Why? I'd love to know. Just gonna, put these periodically because I don't know when it's happening. Then we're gonna say 3. Let's make this one dev 4 and let's put a dev 3 like right before this loop. I mean, that's not really, yeah, sure. Sure. At the end of the loop, we'll put dev 5. Did I run the wrong thing just then? I think I ran the wrong thing just then. We'll see how it goes. It still did the same thing, so it doesn't matter. Yeah, I didn't rebuild. There we go. Can you maybe print out I too, just in case? CC Ataden, thank you so much for the follow. Yeah, we can. Loop. One more rebuild, sorry. It takes about 15 seconds to completely build the OS from code, from nothing up into the actual thing, assuming you have the tool chain. Which isn't bad, but it's not exactly fast. Okay. Serade. Are you sure static pointer cast increments the ref count? If it copies the pointer, then yes. What does that mean if it copies the pointer? If it copies the pointer. Look at this. Dev 5 null. What is happening? How's it magically null now? File allocation table driver try create. Down here? This is just a call. Why it was declared auto. This isn't a declaration. This is just calling it. It's the same as just saying auto I equals 5 or foo. You know what I mean? It's just this. The actual driver is declared to actually return a shared putter, as far as I know. That's not going to go well. Okay. Do you have any cool explanation? What? For the auto thing? I mean, we can go to storage. We can check out the actual file system driver. No, I know. I'm talking about its actual declaration. This here. Are you talking about this auto? It has an auto return type. It sort of does. It has an auto keyword in the place where the return type normally goes. But its return type is actually declared through this syntax over here. It's a shared putter of file system drivers. I now understand what you're asking about, Brainsman. I was wondering why. Basically just because it gets really long to have this on the left side. And the return type of these functions is if we look at the header, right? So we already kind of know, like, when we call these, we're going to get certain things, right? It's all declared in the header. So there's no need to, here's another example. It just shortens it. It's just another syntax, which should call the aliasing constructor, which increments the ref count. So the static pointer cast calls static pointer cast const shared putter u and other, which should call the aliasing constructor, which increments the ref count. The shared putter that's passed in isn't copied, it's passed by const reference. How can it increment it if it's passed by const reference? Is it in here? We do have it here. Okay, what do we have? This one? You and other. This one. Brainsman says, oh, okay, it's just syntactical stuff. Yep, that's it. So we static cast shared putter t element type pointer for other.get, and then we shared putter t other putter. Should this be other.get or something, or putter, or why do we have other here? What constructor are we calling? That shared putter constructor invokes the aliasing constructor. I thought it had an actual secret reason to use auto over a normal return type. I didn't know. That's fair. C++ can be quite cryptic. So what if putter's null? It'll overwrite putter in the control block with null. Is that correct? Am I getting this right? Sorry, it says incorrect. I figured. So what if it's doing this because of return type optimization? Is that a possibility? So if it's calling the aliasing move constructor, then we would be setting null putter, which is exactly what we're seeing. It's a const reference, not an and. I know. I would presume that this one would be called. But it looks like this one is. You know what I mean? Does it have to do with an assignment? It's just confusing why it's going wrong. You know what I mean? It's definitely not calling the and. Okay. Well then, how is it being set to null pointer? If you're so hasty to call me wrong, how's it being set to null putter? Because I see code that matches a very similar constructor, right? It's just literally one ampersand. And it does exactly the problem we're having. That's all. I'm not saying it is this one. I don't know why it would be. But how else is putter being set to null on other? It just doesn't make sense. I'm sure you can understand. What's the point of using a reserved variable syntax with underscore underscore something for a homemade standard lib? I mean, you kind of said it. You answered the question in your own question. Using a reserved variable syntax. That's exactly what we're doing. This is a standard lib implementation, so it can only use reserved variables that are for the standard library, which is this awful underscore underscore mangling. Because if we didn't do this, then there might be some port or some program that we write where we define control to be not control, right? Or control or control, right? And this is totally allowed. This is allowed in C++ and C. However, that would break this if we happen to use it. So by using underscore underscore, it means that we'll never have name collisions. Can I print things here? That seems a little messy, but it'd be cool if we could. There, here. We'll see how much this breaks. Print is not a member of standard. Is that a circular thing? So in file included from format in memory. So format includes memory, so we can't include format. Wonderful. We probably don't want to just... Do we have to forward declare it? If we want to use it in here? It's probably not the best idea. Yeah. What can we do? At this point, it may be worth it to do a targeted GDB run and look at specifically how that shared putter and static pointer cast is happening. So we had a bunch of null devices apparently, which doesn't make any sense, but it's just because loop keeps going. But we get a null device at dev4 after dev4. So can we print it directly after? Created blah 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 blah, and then do dev get. Oh, C++. Sorry, it says, well, admittedly, what bothers me is that when I go to definition on the constructor colon static pointer cast, ClingD actually shows me two constructors, the alias one and the internal private constructor, but the latter accepts a pointer, not a shared putter as the first parameter. I'm pretty sure a shared putter is not implicitly convertible to an element pointer type because there's not user-defined conversion operator for that. So because of that, I'm pretty sure ClingD is just being stupid here. I see. The classic. It's ClingD's fault. Saraid, will you believe me now, please, that the aliasing move constructor is somehow being called? Will you believe me now, please? How else? Because this code in memory does not do that. Something's being moved somewhere. Is there like return value move optimization happening here? Are we somehow calling this one? I just don't get it. I don't think it makes sense. I don't know what's happening, but it doesn't make sense for that constructor to be called. I appreciate that answer. You're not returning other, so RVO doesn't apply here. Yeah, that's what I was thinking. Like, we would have to call standard move like we do here. What if we just, like... So we're creating a shared putter, right? Can we not use static pointer cast and see if it still works? Like, can we do a make shared here? Do we do shared putter to initialize and then call dev? So it says nope. Why do we need to do this here? It's just, this is gonna get messy, but fuck it. This is gonna be... When in doubt, try it out. And we don't want to move it. And we don't want to return that. We want to say auto f equals blah. Sure. This isn't runtime type information, is it? Standard shared putter. Shared putter. So it says no. Okay. I'll trust you there. I'm sure the compiler would scream at me as well, but I just gotta ask. Because I have no clue what the fuck's happening. Type name foobar is required in templates because it doesn't know that foobar is a type if it's in a template. Classic. Still the same thing happening. Can I print out dev.get here as well? Well, doing the exact same thing from here didn't work. Had to try it. So if we just go ahead and go back to our static pointer cast. Is that in the standard? I don't even remember. Is this what it was? I feel like I'm forgetting the template, aren't I? What was it before? Tell me. Static pointer cast. Here's the template. Sure. Okay. I don't think I screwed that up. Is this supposed to be dev.get? No. Okay. Still a pointer part. Okay. Still a triple fault. What did we do wrong? Okay. So we start out where they're fine, and then we call create device, and then they're not fine. So this is wrong. I guarantee you, this is wrong. There's no other. There's no other explanation. So this creates a shared footer to a system device from a shared footer to device type. Okay, let me look at this for a second. What's this actually doing? Creating shared footer to device type, i.e. shared footer devices HCI port. And then we create a new shared footer from that, which points to a new type. Something's wrong here. I don't know what it is. So device type. So we're creating a GPT partition shared footer. GPT partition shared footer. So in devices, I want to look at the constructor. It takes a shared footer to HCI port and a partition entry. This creates a device passing, in this case, a copy of the static pointer cast, copy of dev to the constructor of the HCI port, and then that pointer is static pointer cast to a system device and stored in the vector. Yep. Sounds about right. And at some point there, it's moving it. Is it standard forward? Something's wrong. Where is forward defined? in vector? I don't remember. I could probably just grep utility naturally. I don't understand enough about C++ to know the difference between these two. These are the same. Is that on purpose? If T, so we get a reference to T, and then we return the R value of that. The type here is an L value, so it's not moving it. One accepts and param, the other and. Yeah, so this is an and a T. Do we need to cast it? I guess we do because, well, it's a remove reference to you. What else could it be? I changed. Did I change in memory? Nothing? It's just making it up? Okay. Cool then. Oh, this is annoying. Why can't we just call the right constructor? Do we need a make shared here? Why are we making... So we're making a GPT partition pointer, shared putter, with f and part. Then we do a static pointer cast to system device. Alien Element says, what's up? What's a network stack? Oh, we got a raid. How's it going? If enough of you say something, I'll sing a raid song. A network stack is something we'll likely never have. You know how, like, you're on the internet right now? Your computer's doing that. And I'm writing an OS, so I'm figuring out how to basically, you know, talk to the internets. And the local host is really what I'm very interested in. But we have some silly bug right now with C++ doing the wrong thing. So that's annoying. If this code is actually broken, why was it working before? I don't know. Luck. It just doesn't make any sense. I mean, you see it happening. There's not something happening in between here that we can magically go wrong somewhere else. We're just calling pushback. You know what I mean? Kind of nothing. Thank you so much for the follow. Provode, thank you so much for the raid. I appreciate it. Hopefully you had a good stream, and just dropping them off here. So can we just make shared? What if we just make lots of shared? It says no known conversion from shared putter GPT partition to const system device. So it's saying we can't turn this shared putter into this shared putter. Well, that sucks. And that's why we need static pointer cast, but it doesn't work. Well, this isn't how static pointer cast or make shared is supposed to work either. There's something going wrong here, so I'm just trying things. It's not how it's supposed to work. We don't know how it is working, because everything's broken, my dude. I mean, what could be wrong in shared putter? We were just looking at that. What would be wrong? How would we get null? So it says, I don't know. But something isn't right and I don't know where. You're very helpful. This is stupid. I hate shared putters so much. Can we make this? Sure. So it says, oh god damn it, I know why, damned iterator invalidation. Aren't we appending to a vector while iterating over it? Possibly, I don't know. Yeah, we're looping over system devices. I didn't do this refactor, you did, Saraid. This wasn't a vector. You broke it, Saraid, you broke it. So we push to the back of a vector. Why is that a bad thing? How does that invalidate an iterator? Can't we fix that by just like getting a new iterator every time? This is really annoying. So when this was a linked list, aka a sensible data structure written by me, everything was fine. However, due to Saraid's magical refactoring of all the linked lists because he hates them so much into vectors, there's now undefined behavior and we're having troubles with iterator invalidation. How fun. So we have to push new devices into a thing every time in every single one of these loops because it's a vector and not a list. What a great refactor you've done, Saraid. So we just can't do this. We should be able to loop by index because we need standard deck. That'd solve this. Yeah, or just use a linked list like it was and don't over-optimize everything. There's no reason. Yeah, looping by index works because we'll recalculate the iterator every time. Ugh. Auto reference. dev equals system devices beta I. Sure. Provode, I'd love to see a PR where you enable, you know, a SAN in a kernel in a freestanding environment. No exception. Yeah, just you set up, go for it. I'd love to see a PR where you can get a SAN. That'd be sweet, Provode. It's not like I don't know what it is. So it says just system devices at I. Is that fine? I mean, it's the same thing. It's an overload. What do we do now? We have to replace this with that. Okay. I equals 0, I is less than system devices dot size plus I. Auto dev is equal to system devices at I. Standard vector doesn't have a data member. Middle Cloud says, sorry, I'm going to sleep. Have a good night and good luck. Thank you so much, Middle Cloud. No need to feel sorry. I just appreciate you for tuning in. Thank you so much. Shout out Middle Cloud. Everyone give him some love before he goes. Middle Cloud is the most recent contributor to the channel, helps keep this thing going and justify it, spending this much time on it. Sorry, it says, goddamn iterator invalidation. Seriously. It's not often that I have bugs because of this, but whenever it does happen, it's usually rather horrible. It's usually because you're using a vector when you shouldn't be. The reason I didn't catch it is probably because we're not calling pushback directly here. Yeah, we're looping over a thing, and then we were calling a helper function in system, which happened to also push back to that thing, which made it not obvious. I agree. I didn't catch it either. Dev, okay, one more time. Matt. Do I have to call size as a function? I feel like I'm screwing that up. Size is a function, yeah. I got it right the first time. Ugh, I hate iterator invalidation, and I hate C++. I better see a whole bunch of non-null pointers, or I'm gonna freak out. I'm gonna flip. Hey! We have so much reads. Don't worry about it. It's working. PogChamp. Okay, it works. Dev is no longer null. Jesus Christ. Okay, I gotta figure out what I don't want to print out now. I don't want to print out all this garbage. Oh, hold on. Use create device now. We just called system on F, which is this thing. Blump. What just happened? Yeah, blump blump. Okay, can you please not be null? That would be oh, F isn't gonna work because F doesn't exist. Let's not worry about that for now. Because we're just interested in dev and whether it's null or not. We can now outline all those functions we just inlined, pretty much. PogChamp. GPT partition, read, file allocation table. And what else? Okay, we should be good. Jesus Behebus Malebus. That was bad. Okay. Oh, my foot. Oh, it's going to sleep. Oh, my foot's asleep. Pins and needles. Oh my god. The woes of a programmer. Jesus. Oh, it's so bad. Oh, I can barely stand on it. Oh. No. It can't be. Okay. Oh my god. So it says, this was my first iterator invalidation bug in like a year, I think. Just when you think, I haven't had any bugs because of that in a while. So yeah, in some sense you were right. It was being moved, just for different reasoning. Yes, just slightly different reasoning. It was being moved just in literal memory. References being pointers under the hood really ruins everything. Imagine if a reference could move when the vector moves. That would be incredible. So we've done it, and we should now not have a problem creating having our network card actually set up. So Jesus. So how do we do this normally? Normally we'd do something like this. And that's how that would go. And then we'll include provide an implementation for this external symbol defined in this header. So this is where it will actually be stored. And ideally, we can just have it be nothing at first. I don't think we even... Do we call global constructors? I can't remember if I even do that. I'm not sure if it's worth it. Sorry, it says relative pointers go burr. Yeah. Linked lists are so much better. So we have GE1000, which we're going to want to create an E1000 driver for, which means that hopefully we can get the MAC address. How do we do this? We are basically just going to want to construct one of these bad boys. Somehow. Why is this not... Why are you mad? Use of undeclared identifier. Okay. What? Oh, because I know why. I now know why. We don't include it. It's as simple as that. Okay. And basically, C++ moment. Pretty much. basically we're going to need some way to make this thing. And we're probably going to need something like the device header. What is it? Header 0, PCI header 0. So we have PCI header. Should probably do this in the standard notation for LensorOS. Give it another 5 years or so and we'll have modules. And after that, no more goddamn header files. I doubt it. I doubt it. Hopefully, but I mean, you know the track record. And we'll say we have one with a PCI header pointer. Header. Header. Gbus. Okay. So, why are you mad? No type name PCI header. Oh, PCI header 0. Sorry, it says, I'm sure we'll have modules until I'm pretty sure we'll have modules in C++ 26, honestly. Experimental support is there. It's just a bit janky at the moment. Just a bit. Unusable means janky, then yes, I would agree. So this is going to be dev. Why are you not auto-completing? Weird. Is it going to be dev get? I don't feel like that's right. It's going to be dev driver data. What is it? Do I need to cast it? That's probably what I got to do. I got to static cast into from the system device into what? Into devices E1000 device. And then this is going to be pointer. Can I do that? Okay, then we're gonna have devices E1000 device E1000 is equal to blah. Sure. And then this is gonna need to be a pointer question mark. Okay. And now basically we'd like to use the header to create an E1000 yeah, like this. Does this break horribly? Shared pointer system device. Okay. Is this what I do as well? Yeah, this is kind of the pattern. This could probably be a helper function as well with a template, but it's fine. Oh boy. Undefined reference to E1000, E1000. Ah! That would be it not actually being in here. There we go. Add it to the build system. One more file. Undefined reference to... Well, I don't think I need, well, I need that because it just needs to do nothing. Null putter 0. We could add an as templated, oh man, I'm losing my voice a little. Get push, get paid, followed. I feel like I've seen that name before. Thank you so much for the follow, I appreciate it. We could add an as function to the thing. That's what I usually do with variants, which this sort of is, pretty much. Well, it seems to be still working. That's pretty pog. Do we have some printout or anything like that? Question mark. We don't have anything happening, so that's probably a good sign. And now we have to think about what actually happens here. And let's also go to E1000 and include a bunch of stuff. So can I like do this? Is this kind of a mess? I think this is fine. It's not perfect. So we're going to do register control. So maybe all of this should be defined in the actual implementation. That's probably what we should do, I think. Or just have a separate header. Or this stuff. So we have status, which is 8 apparently. We're just going to do something like that. Okay. Just going to get some basics in here. What else do we have? Control extended. iMask. P0. Right control. 100. All of these seem to be similar. How many are there? 5? Is that how many I have? Low, high, len, head. Oh, RX descriptor. I see now. And low, 2800, 2804, they're all 28. 8, 018, okay. 28, 04, 08, 10, 18, okay. Beautiful stuff. I could just copy and paste. That's, I like to get a little familiar with this stuff. So this is the RX delay timer register. Okay. Descriptor control. So RxD cuddle. That's OX3828. Yeah, RADV, which is the interrupt absolute delay timer. Okay. Rispida. Did I do that wrong? Reserpida. I did. Reserpida. OX2C00. Small packet detect interrupt. I don't know what that means, but I'm sure it'll come in handy. Transmit interpacket gap. This is probably a command register. Set link up. I'm not sure what this means, but that's fine. E control set link up. Okay, that's SLU. register control enable or receiver control. We'll figure it out. Our code will end on the left one. How many? This is going to get a little long. You probably just do this. I'd probably just copy them because I'd probably make a typo somewhere. That's fair. That's why you just get good at typing. Upe. Promiscuous enabled. Did I somehow get rid of that? I did. We have upe. We have mpe. We like mpe. Multicast. Promiscuous enabled. Am I reading that? Promiscuous, yeah. We have 6, 7. Oh, we don't have 7. What? This is a little sketch. So we have 1 to the left 5, 0 to the left 6, which is a little scary. Loop back mode to none. Long packet reception enable. LP. So we got lupe, mpe, upe, and subupa. We got album phi. Set loopback mode to physical, I would presume. And that's 3 to the left 6. Quite confusing. Now we have 0 to the left 8, naturally. And then this says free buffer threshold is 1/2. Whoops. Is 1/2 of RDLen. RDMTS. RTCL. Is that on purpose? I feel like this is a typo. RTCL? I'm going to go with RCTL. Fix me. Possibly this should be RTCL. Sure. RDMTS half. Okay. CTM 8. Now what do we have? A bunch of multicast offsets. Bam, buffer sizes, transmit command, TCTL register. Okay. RCTL, MO 36. 0 to the left 12. That's just confusing. I wonder if I even need any of these. It'd be pretty funny. Maybe it's just saying like this is at offset 12. I don't even know. Okie doke. 0, 1, 2, 3 to the left 12, multicast offset 47, 36. 46, 35, 45, 34, and 43, 32. So it's just where. Interesting. Okay. What does 0 to the left 12 even mean? It's a fancy way of writing 0. Basically, we have presumably some big number, right? So to the left 12 would basically be saying that 0, 1, 2, 3, these are 2 bits wide, right? So it'd be saying that basically you get the 2 bits within this 4, within this nibble. That is 12 to the left. Oh god, that didn't work. Does that kind of make sense? So you have these 3 bytes, which is 3 nibbles, I should say, which is 4 times 3 bits, which is 12, to the left 12, and then you're just saying there's a 0 here. Hopefully that makes sense. Where Mo? Bam! Hashtag define arcadal bam! And that's 1 to the left. 15, broadcast accept mode. Arcadal VF. We get the VF, 1 to the left 18. VLAN filter enable. Just confused why 0 to the left 12, isn't it just 0? It is 0, but this is part of a larger number. It's part of a packed bits. Hopefully that makes sense. You have a full number, there's going to be all sorts of things in the hardware, and you're just having to extract, I want this one specific portion to be 0. Hopefully it makes sense. And we did VFA. But you can just write 0. There's no, it's just indicating to the programmer that, hey, this is a field of 2 bits at within this number at offset 12. Canonical form indicator enable and bit. CFIN. 1 to the left 19, 1 to the left 20. Well, that's a mess. But yeah, there's no reason. It's just for hardware specification to say, help you out and say, hey, this is what this means. It's why this is 0. Discard pause frames. RCDL, CFI, discard pause frames, DPF, which is 22. This is some funky definitions. PMCF. Pass Mac control frames, okay. Secrecy. Strip Ethernet CRC. Oh god. Buffer sizes. I'm not doing that by hand. There's no reason to do that by hand. What if we wrote 16,384 in some crazy way? Transmit command. This is what I need to get back into. Why is this all messy? End of packet. Okay. Insert FCS. Don't know what that stands for. IC insert checksum. At this point, you can just copy the rest, I'd say. I think you've been writing these down for like 5 minutes now. That's fine. Doing this helps me get understand what actually code there is, not just like feel overwhelmed. So I agree it would be faster, but I don't think that's what I'm looking for. So we have report status, insert checksum, report packet, sent. And one to the left, 6 and 7. VLE, which is up above VLAN packet, yep. I mean, it's mostly just constants that don't make too much sense at the moment anyway. I mean, they make a lot of sense to me. We basically are gonna have, this is the API of the hardware, right? This is kind of the best you can get to understanding what's going on. And what's a possibility. I agree it's not necessary, it's just something I'm doing, but it helps me out. So we have cold shift as the longest one. Something like that. Oh, and then actually put in N. And transmit enable. So this is the transmit control. Okay. Ooh, PlayStation Plus. Add short packets. Okay. CT shift. 1 to the left. That's just 4. Okay. 12. Cold shift. Collision distance and collision threshold. Software X off transmission. I don't know what that is. See, that one's not that helpful. 1 to the left, 22, switch off. RTLC. 1 to the left, 24. Retransmit on late collision. Okay. And then we have Batista. I like Batista. Oh, and there's an L star. Descriptor done. 2, 3, okay. Excess collisions. Imagine using 4, not 1 to the left 2, shaking my head. LCTU. So excess collisions, late collision, transmit, underrun. And some sizes. Okay. Jeebus Creebus. Now we have a struct which is packed. There's actually 2 of them. And we have the E1000 RX descriptor. Sure, we'll do desk. We'll see how that goes. And the transmit descriptor. How beautiful. And I think I can make this volatile. And everything within it will automatically be. Checksum status errors special. Okie doke. You should also just be able to do struct GNU packed in C++. That's probably true. Everywhere else there's packed structs across the code base. This is how it's done. So I agree that we should do that, but we should do that everywhere. So I'm going to add that to the to-do. So it says X off, X on generally means pause, resume transmission. I see. We got to wait for org mode to load. Just one moment. Okay. To do, use, what is it? GNU packed instead of, oh, I can't do that either. Use GNU packed instead of attribute packed. Not done. To do. This one I think is done, but I'll get to that. It's very close, so I'm just going to do this. How is it different? So this is status, this is CSS. There's no checksum. There's a CSO and a CMD. I would love to know what those stand for. Okay, that's cursed. Okay. We have MMIO helpers as far as I know, as you can see. So we're good there. What did I do? You can't do volatile struct because a struct type can't be volatile, only an instance of a struct. What? I was pretty sure that was fine. Defines that a type is volatile. I'm not seeing anything specific, but I could easily be missing it. As mutable. A member structure. So can I not do, yeah, I can't do it. Volatile is like const, you can't use it this way. Yeah. I'm starting to get it now. So just whenever we create these, we could do that. Or we just have to do this. Beautiful stuff. I could swear that you could make a struct volatile and all of its members would be volatile, but maybe I'm misremembering. See the Godbolt link above. I see. I'm probably misremembering. It just seems interesting. Bar type, base address, blah, 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 flag indicating, write command, read command. So we have write command, which says bar type. What is bar type? Type of bar 0. Does that ever get explained? That never gets explained. Okay. Constructor pointer to all the configuration data. This is some messy code. PCI configuration header. So we have bar 0. What do we do with bar 0? I feel like I remember that here. So that's bar 5. We get the A bar, which is an HBA memory thing. So apparently bar 0 matters. I wish this would be more outlined or explained. The hell does bar 0 do? So we have bar 0, which is a U32. Expression result unused. Yeah. So let's look at a PCI header 0 and look at what... Okay. Goddamn Windows. I don't even know what I pressed. It might help to know what we're actually supposed to do. Yeah, that's not going to work. No one's going to tell us or help us. Okay, so with this PCI header 0, we basically have a device header followed by a bunch of stuff. And the idea is... So what if by bar type and type of bar 0, what if this just means literally bar 0? Because the hardware should tell us how to use these base address registers. So what if it's literally just the number? Can I print the PCI header? Is that a thing I have? I don't have like print header anywhere here, at least. Here it is. It's just not a function. Can fix that one right up. That's the device header itself. That doesn't actually print bar 0 or anything like that. Because that's kind of this thing down here. Where did it go? Here to go. Okay. This is a mess. I love it. Format, please. This is a mess. A mess, I tell you. Yeah, I don't need all of this. I don't need all of this. Jeebus. E1000. Blup. Show me things. So... Okay, why are you mad now? Namespaces, okay. Deal. Deal. Okay. That's cool. So can we now print that stuff out? That'd be great. And then like also print the thing out. Where are we at? What's it called? Print device header? Okay. Why are you mad? Oh, this and. And hopefully this doesn't blow up and we get the proper pointer and everything is still mapped and things work. Sorry, it's Windows moment. Yui696969. Thank you so much for the follow. It worked. It worked. Cool. Okay. Device header at blah, 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 blah. Unknown progress, Intel Corp. Unknown. Okay. Now I would like to print out the extra bits. Sonaris says, Hiya, saw your video on compiler on my recommended and really enjoyed the first episode. Glad to catch you live. Thank you so much, Sonaris. I'm happy you enjoyed. That's definitely the one that most people catch. I am happy you enjoyed. We're working on the OS right now, not the compiler, but it is all good. So I want to print out a bunch of stuff. Bar 0, header, bar 0. One, two, three, four, five. 1, 2, 3, 4, 5. What do we got next? Capabilities putter. Okay. Card bus sys putter. Is this in order? I feel like this is not in order. Card bus sys putter is first. Sonaris says, working on my own compiler in Java. So excited to see where I end up. Maybe I can get some inspiration from your series. Awesome. Sonaris says, also the own OS thing sounds really awesome. Thank you. I appreciate it. I work hard. I'm just gonna do maybe something like this. Okay. That was easier. And then we just kind of have to do the same thing. Make sure to fix this. Okay. There's not a comma here, which is going to be a problem. I think I need to do this, this, this. Okay. That sure was a mess. It worked though. So we are now building and booting our new OS, our OS. Just gonna give another shout out to the most recent contributor of the channel. Thank you so much to Middle Cloud for supporting the channel with their $10 donation. I freaked out a little bit. But yeah, shout out to Middle Cloud for keeping this channel going. Well, it's working. What did we print out? Bunch of stuff. Bar 0 is some large number. Bar 1 is some number. Subsystem vendor ID, expansion ROM base address. Should probably do like X. So bar 0 does not appear to be the proper thing. So where's the E1000 actually talked about? Get bigger. Bar type. Where happen? This is receive init, TX init. Where's actual start? Get PCI bar type, and then get PCI bar IO and PCI. Okay, well, this is an interesting one. So the bar type is apparently some PCI thing that I don't know how to do? Question mark? What would be the type of a bar? I'm just trying to think. In all my PCI journey, I've never encountered bar type or how to get the type of a bar, because a bar is just a base address register. Does he have a link? Of course not. PCI bar type. We're just going to go for it. Oh man, do you hear me losing my voice? Make sure you're drinking water. Hey, look, this is exactly what we're looking at. There are 6 bars. Okay. The wiki page for PCI configuration space. For all PCI bars, for memory bars, for I/O bars. So bit 0 is the type. Okay, chat. Okay. So I think we can just make this a helper in PCI header, and we can say this should probably be packed as a struct, just another note. Something to note. The problem is that we need to get bar type. So get bar type. This is going to be literally one of memory or I/O. I'm just going to do this then. Okay. We could have this like we just feed it a U32 and it returns this. That might be a better idea. Instead of having it requiring this header to do it. We'll do that. So basically the same thing. Oh man, excuse me. We should just be able to do this because it's C++. I really wish it wouldn't be doing that. And now we have get bar type U32 bar. And then we can say return bar and 1. Bar type I/O. Otherwise, memory. So basically, if the first bit, the 0th bit, I guess I should say, right, 1 to the left 0, the 0th bit, right, if it's set, then we return bar type I/O, because that would mean the region type is 1, and bar type memory, which would mean the bar type is memory. Okay, if you're using it that way, then I'm making an enum struct or enum class. Sure. I think I could do inline if I really want to. Is this allowed? C++? I think that's fine. I'm not going to get ODR. Am I going to get ODR? I might get ODR, so I should probably just do this. I can never remember the C versus C++ rules for that, so I just tend to do this. Why are you mad now? You're not. You were lying. Haha. So now that we have a way to get the bar type, Can we set the bar type as a member in here? Should probably have an invalid bar type, I'm now thinking. What? So it says inline. Nope, it's either 1 or 0. I don't see how it could be anything else. That's true, unless the actual device header isn't a thing, in which case we're going to have other problems. You're right. You're right. Just what's the default then? No default. Fuck it. Caution to the wind. Okay. So we have apparently the bar type now. So we should be able to say bar type is equal to PCI get bar type for PCI header bar 0. Then we're going to say bar type is equal to PCI bar type memory base address register type. What a name. I guess I'll just do some printout. Bar 0 is memory. Else bar 0 is IO. In case you're not aware, what it's talking about here is that we are basically going to have bar 0 refer us to something in either memory or an IO space. So x86-64 computers have multiple address spaces, one of which being memory, aka RAM, and the other of which being the IO port space. Well, it's still running. What do we got? Bar 0 is memory. Hallelujah. That makes things very easy. So, because bar 0 is memory, we now know some things. And we can start implementing some things because we have some data now. Where are we? So, detect Eeprom, write command, read command. Okay, so we probably want write command and read command. That way we can actually do things, right? We can read from an address and get a 32, get 4 bytes. What does read command do? I guess it just gives us 4 bytes. Okay, whatevs. This is a little odd. Okay. So if we take a look at membase, I'm pretty sure we just set it from memory, from bar 0 directly, and it's an address as far as I know. So we're just using the IO and memory bars of the actual PCI, which if we take a look at, did I close it? PCI configuration space. Beautiful. Region type for all bars. For memory bars, 2-to-1, locatable, blah, 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 for IO bars. So I don't actually see that certain bars are certain things. So why is it acting that way? Bus device function, yes. 4 kilobytes, yes. Bus enumeration, cool. I'm not seeing it. What am I looking for? Get PCI bar IO. What is the IO bar, base address register? So can I look into PCI base address register a little bit deeper? Sure. Let's go to all of them. Do we have base address register? We do. They can hold memory addresses or offsets for port addresses. Memory address bars need to be located in physical RAM. IO space bars can reside at any memory address. To distinguish, you can check the value of the lowest bit. The following table describes the two types of bars for memory and IO. The type field of the memory space bar specifies the base version and where in memory it can be mapped. If it has a value of 0, then the base register is 32 bits wide and can be mapped anywhere. Value of 2 means the base register is 64 bits wide, can be mapped anywhere. Value of 1. Okay. Mask the lower bits. Naturally, okay. For IO space bars, you calculate bar of X, and to determine the amount of address space needed by a PCI to save the original value of the bar, write a value of all ones to the register, then read it back. The amount of memory can be determined by masking the information bits. Christ. I'm not sure what it's asking. So what does this actually mean when it says get PCI bar IO? Can I search for that? This is the only occurrence, fucking naturally. Enable bus math? I don't even know what this means. Okay. Basically, here's what I'm thinking. The PCI bar is going to be the one that we just tested. So are both of these just 0? Because it has to do with the bar type. Let's go with that, huh? Let's go with that. I don't actually know the answer, but I don't think it matters. So what are we going to do? We're going to say that we have some sort of address. And this is going to be memory address. And then this can probably be a union. I don't really need one. It's fine. We'll just have 2. We'll have it be a union because we only ever need one of these at a time, I would presume. So we have the bar memory address or the bar IO address. And we basically want to say if bar type equals memory, then bar memory address is going to equal PCI header bar 0 and then this is going to be what? So this is going to be like usize max. Tolibertix, thank you so much for the follow. Orange Tuba, you as well. Thank you everybody so much for being a part of this wonderful community. Be sure to check out the Discord if you would like announcements every time I go live. It is a ton of fun, I promise. But yeah, check it out. Okay. And basically, we're going to need to do usize -1 right? Is that how that works? And usize -1? I think that'll do it. What are we doing in here? I swear it was in here somewhere. So for the membase and 3? Sure. I guess it's not 3 versus negative, although negation is kind of the same. So we could just do usize 3, but not that. Okay, okay. R0 and not usize 1. Okay. Goes memory address equals blah. Bars IO address equals blah. Okay, and hopefully we get some stuff out of this. What did I do here? Ah, that's what happened. I opened up a new thing on accident. I was wondering where all of this went that I was looking at. I was like, I swear I had stuff open. Well, that's surprising. It's still working. What do we get? Bar 0's memory address equals some hardware address. Intel Corp. Bar. Cool. Very cool. I don't think I need this one anymore. So now that we have the bar IO address, we are going to need to map it. How do we know the size? Are we just going to map a page? Map the memory address into your page tables. Well, yeah. So map the memory address into the page tables for what? When do we actually use membase? Read MAC address? Okay. So we're dereferencing MAC and membase MAC 8. So we're iterating 4 bytes at a time. What? So we say if the first 4 bytes are not 0, then get the next 6 bytes at this base address. That's a little sketchy, but okay. If Eeprom exists, what? So what is Eeprom? Why Eeprom? What Eeprom? So I is less than 1,000. So we say val equals read command Eeprom if val Eeprom exists. So we just test 1,000 times whether or not this returns 10. That's a little messy. I think we could just put an IO wait in here and it'd be fine. I don't know. So detect Eeprom just says if there's an Eeprom. But if there's not an Eeprom, which he mistyped as Eeprom, there's some differences, but overall not that different. It's kind of confusing. Very confusing, in fact. And then we say data equals very interesting. Very interesting. First thing you'll need after in the existence of the Eeprom. So the existence of the Eeprom apparently matters a lot. So let's figure out how to code this. So there's some sort of electronically erasable, programmable, read-only memory. TFZ, thank you so much for the first time chat. If I understand correctly, you're building networking for your own OS. Yep, that's exactly correct. LensorOS is a completely free and open source bundle of software, and it's available. Link in the description, baby. Link in the description, but also link in chat somewhere there. But yeah, it's this is the OS we're working on, and I'm working on networking exactly as you said. We are working on a hardware driver for the E1000 series of network cards. And we are just about to be able to tell if the EEPROM exists. Can we only do one of those? Weird. So, where are we at? We need to detect if the EEPROM exists, which I think we can just do as a little... Yeah. We'll detect EEPROM, and then we can just do this. Return false, and then we're going to do... It is possible to delay the CPU by a microsecond. So this just waits. So we basically need to write a command to the... That's right, so we're going to need write command and read command. So it says that union seems a bit unnecessary and also generally not suggest using unions because they have complicated mechanics in C++ with constructors, etc. Yeah, it's not necessary at all. It doesn't matter. I'm not worried about it. They're just, it's two of the same thing. It doesn't matter. It's an integer. So to detect the EEPROM, we're going to have to do the thing where we write a command, I believe. So to be able to write a command, we're going to have one of these two things. So I'm going to copy and then alter these two things because they're rather close. We'll have write command and read command. Why not? This is horribly formatted. Why is there so many spaces? Braces. All around nutcases. Okay. Or memory address plus P address. P value. Why do we have everything P? Is it a necessary thing to have? I don't think so. Not sure what just happened. Okay. And then we have bar IO address. Is this not how that works? It's volatile, right? Okay. I may not even need to do this. This is such messy code. I'm so glad to fix this. What are you mad about? Could not match volatile T pointer against unsigned long. So this needs to be a volatile U32 pointer. That's messy. Sure. I think I have like outle 16, that's what it is. I did the sensible one. Out L, is that? This probably means 32. So to write a command, we just out address and value. And this is going to be at the bar IO address plus 4 value. Okay. I feel like volatile write U32 would be simpler. Does it work? I feel like we still have to do this cast. Unless the memory address isn't a pointer because MMIL shenanigans. Yeah, it's exactly that. The U32 just does the value, but it's fine. It can do that. So that should be write command. And we copy that and do a read command, which is slightly different. Because we now have U32, U16. Wait, okay. I want to read from address into value. And then what would I like to read? I believe a U32. And then this has to be volatile U32 pointer once again. Sorry, boys, this is getting a little messy. And then reading had some weird thing where we out then in, right? So we out the, oh, okay. So we out the address, and then the value here should be whatever the value of this address is. So we just need to read 32. There. Why are you mad? In 32. Cool. Trade says, this right now reminds me how every time I watch Blood, I'm reminded just how much I despise word wrapping. Do you want me to truncate? instead, we can have it truncate. I don't mind. It don't bother me. TFZ says, I have tried to make my own OS before, never got further than switching to protected mode and drawing some basic text though. Lol, you know of any good resources for more advanced stuff like user mode or scheduling? I got to user mode pretty much entirely through the OS dev guide. So wherever this is, I think it's bare bones. I can't remember. Is it here? We have booting the kernel. I don't think bare bones gets into user space. It's got to be... Yeah, this is most definitely it. I didn't follow this exactly, but I took a bunch of help from here. And then once you get your cross-compiler working, you're kind of good to go. As far as user space, it's very easy to switch to. You just make a trampoline. TFC says, okay, gonna look at that, thanks. Of course. Where was I? Was I even here? I wasn't here, I was here. What do we have now? So we should now be able to read and write things. Supposedly. So these look to be good now. In which case, detect Eeprom can now actually begin to work. So we want to write 1 to the Eeprom. So when we write to register Eeprom, write command then says memory plate. Okay. So this is like an offsetted read write from the base that we're given, the base address register. We want to write 1, wait, and then read it 1,000 times in a row. In case it is just taking a while to be set. Cool. And then we can say ++I. We're going to be reading Eeprom. And then basically, are we going to be reading this? We're going to say if this and 16, right? It exists. Otherwise, keep going. So if read command, Eeprom. So we already did an IO wait, so it should be happening. Everything should be good here. We could probably do an IO wait here. That way this happens before this does. Doesn't matter what order. It does matter what order these happen in. Okay. Ooh. So we now have detect Eeprom, and then we can say here Eeprom exists equals detect Eeprom. Standard print. Exists. Else Eeprom does not exist. Oh man, I'm losing my voice. So bad. I'm gonna have to go soon. Otherwise I'm not gonna be able to speak tonight. Mind of Walter, thank you so much for the follow. I appreciate it. Welcome. Welcome to the club. Attempted to write to a page that is not present. Oh. Silly, silly me. I didn't map the bar. Haha. What a joker. Okay. Map pages, please. Here, just map one page. Map one page. So the virtual, we're just gonna go for this type of thing. Which, while you do this, 3 hours into streaming, it's like, hey, you want to open up your dashboard on your phone? No, Twitch, I don't. Okay. Whoop. Can we get this bigger again? This is getting a little messy. Why can I not see memory map? I don't know, it's being weird. It won't show me. What is memory map? What does it need? You gonna work now? No? Okay, there we go. Virtual address, physical address, mapping flags. That's what it is. I forget how things work. Uh-huh. Page table flag. We don't want user space writing to this, I'm sure. Present and read write should be enough. Initializing map, void pointer, U64. Well, that seems fine. What's your issue? Var IO address. Oh, it's just saying these aren't void pointers. What just happened? That was odd. I went up here. Okay, yep, that was odd again. That was, I don't even know how to explain what happened there. I was trying to insert parentheses. Hey, it did it again. I'm trying to insert parentheses and it's just going, yeah, you're not doing it right. Sonaris says, for how long have you been working on this OS project? Oh, it's in the thing. Work on LensorOS began on January 9th, 2022. So, a year and 3 months. That was fun. But I took like a 6-month, 8-month break. Does Eeprom exists? Eeprom exists. Okay. It works now. Phantasmo. So we now have if the Eeprom exists. Why did we need this? For Eeprom read. Why do we need Eeprom read? To get the MAC address. Okie doke. Chat, I think we might actually get the MAC address. I didn't know if I was going to be able to do it today, but I think we may actually be able to get it. Which would be pretty pog. Where are we at? The MAC address. We're gonna need read Eeprom. Is it U32? What do we actually get? Yeah, we read 4 things at a time. So we read Eeprom at an address. U32. I guess I didn't need to do that. I already got it. So if the EEPROM exists, we do some weird reading. We write the address to the EEPROM, the address to the left 8, and then we say read until we get that bit set. And then we, okay, so there's some funky stuff happening with the hardware. We're getting a 16-bit number because some of these bits, the lower order bits apparently, refer to flags and things like that. Okay. This one OR thing is kind of weirding me out, but it's fine. So if it exists, then we want to write EEPROM. We want to write 1 plus this address to the EEPROM. I see. So we write 1 to the EEPROM and see what we get. And if we get a certain value, then we can write 1 plus an address to that EEPROM register. And then the value there will be updated. Data equals temp, temp equals read. Okay, okay. Very confusing. So we need to write to the EEPROM 1 or the address, ORed with the address, and then we need to read over and over. To do, maybe put a max spin so we don't hang forever in case of something going wrong. Something like that would be smart. Write command. And this is going to be reg EEPROM because we're actually going to be reading from the EEPROM memory. And then we're going to write 1 or value, and value happens to be address to the left 8. And it should be a U32. I can probably use the proper C++-ness. Write address to EEPROM register. Read from EEPROM register until specific bit is set. That's kind of all I have, right? And then we're going to say U32 out is equal to what? We'll just start with 0, why not? Return out to the right 16 and 1, 2, 3, 4. So this is going to be a nibble per F, which means byte, byte, 2 bytes. So this is a 16-byte thing. I wonder if this should be U16. I don't know. And then we're just going to say temp 16 and OXFF. Okay. Then we're just going to say out is equal to read from the Eeprom, right? So out, this might be simpler as a do while type of thing. So do out is equal to read command while, so this thing and 1 to the left 4. So while out, okay, so this is our end condition. So this could be a forever loop or like this. I think this is fine. Do we need a thing here? Do out is equal to read command while out and 1 to the left 4 is not set. Sure. So it says, so would you prefer writing the entire stack yourself, or should I take a look at implementing e.g. IP if I have time to do so? I'm not fully, okay, as long as it's not like, here's the network stack, you never have to touch it again, it's cool. You know what I mean? As long as you don't like, here's all of sockets and all of IP and all of TDP and all of, or TCP and all of UDP and, oh, I also did DHCP and also DNS resolution and also, like, I feel like as long as it's not that type of PR, we're good. You know what I mean? I would like to be involved somewhat and understand, like, the progression. But if you want to write, like, IP protocol, which is, as far as I know, just puts a header in front of some data, right? If we actually look to the network, I guess that's network hardware. Not necessarily what I wanted. It wasn't, where's the page we were just at? Network stack, that's right. This is where we started. IP sits on top of Ethernet and is required to send data on the internet given an IP address. The most common version, IPv4, IPv6. Yeah. So basically, we're building this right now. If you want to go ahead and build this, that's fine. IP also involves IP fragmentation, etc. Yes. Yes, it's an entire layer. There's a lot of stuff there. But yeah, feel free. PR is welcome. That would be sweet. As long as it's not like, oh yeah, I implemented IP and ICMP and UDP, oh, and then I did DNS and DHCP and also TCP and also I did some HTTP. It's like, don't do all of this and we're good. Right? I mean, even if you can do all of this, feel free to do it. I'll probably be a stickler on like, I need to understand this first before merging. So we read the Eeprom if it exists in this way. If it doesn't exist, how do we read it? But yeah, Suraid, go for it. I'm giving you the thumbs up. If it doesn't exist, we just do a different shift here. Huh. I'm not going to worry about it too hard. One and one. I feel like this may be easier to do. So this is going to be calculated address is equal to, I guess technically I should be doing this. Success mask equals 0. feel like this may simplify things. Just a bit. Cool. Okay, now we set the mask. Sure. I feel like that's a little cleaner, less code duplication. Can put this at the actual spin now. Okay, so we should now be able to read from the EEPROM some value at some address. Why do we need to do this? Because we need to get the MAC address from the EEPROM if it exists. It looks like we're getting 16-bit values out of this. So I'm going to actually have it return the proper type. Are you mad now? What? Oh, it's just not reloading. So now here, not even here, we need a new thing. And this is going to be void get MAC address. Requires Eeprom detection and requires bar type and Eeprom detection to be done already. Cool. Okay, so to get the MAC address, we're going to say if Eeprom exists. We're just basically doing a byte ordering here, right? I feel like memcopy would be much more efficient here. Am I crazy? We set the low bit and then the high bit. So it's a backwards byte order for each of the bytes, but not for all of the bytes. Crazy. So we just read. I don't think memcopy matters here, candidly. I was just saying it might be easier to read, but we have to switch byte order, so it has to be like that. We want to EEPROM read 0. Read EEPROM. I'll always get that backwards. Yeah, sure. We'll do that. So MAC address at 0 is going to be each byte order of each 2-byte pair is flipped, as far as I know, right? Value to the left 8. Value to the right 8, because it's the high bits, duh. And then we just continue to do that. all the way till we're done. If the Eeprom doesn't exist, then it's simply... I'm kind of confused what's happening here. Shouldn't we be doing volatile reads? These should be volatile reads, should they not? I guess the Eeprom might not be... So the Eeprom won't change out from under us. It's not volatile. Why is OX5400 in here? Fuck. That's a magic number and a half. Okay. Lovely. To do. Figure out what OX5400 is. That'd be step one. So it looks like we get a U8 pointer of the bar memory base. Is that all that's happening here? We get a U8 pointer from the base plus 5400. Also, what do we do here? Membase. To do what if IO address. Okay, so we have some to-dos to fix. So it says that the text above explains what OX5400 is. Does it? Oh, nice. If an EEPROM exists, it will read. Otherwise, it will read it from address 5400 where it should be located. It's just a more magic number. It is very important to detect if an EEPROM exists. Yes, yes, yes. It's the address where it should be, naturally. So then we need 6 bytes. Sure. Then he actually returns a bool because this can fail? Does this realistically ever fail? Why are we doing this? Let's not do that and see how bad it goes, right? Then we're just gonna say so if the first 4 bytes are 0, do some crazy shit. I don't know. It doesn't even matter. It doesn't have to be that crazy. Just say like error. Right? Something like that. And then we can say there's an error and it's that First 4 bytes of MAC address are 0. Hopefully that never happens. Panic here, handle this more gracefully. I don't know what would be the thing to do here, but this seems fine. And now that Eeprom exists, fix me store state 1000 is currently in, and assert that state is greater than or equal to expected state to make sure that these things are initialized. Sure. That way we know that bar type EEPROM has been detected, etc. when we try and get the MAC address. For now, we're just going to use ordering of the constructor. We're going to say get MAC address, and then we're going to print the MAC address. How do you print a MAC address? What is a MAC address? Anybody know? Black White Cookie, thank you so much for the follow. The text, sorry, it says as hex. Is that true? So, oh, here's what we need to check if it matches. Ha, okay, what is this? 1, 2, 3, 4, 5, 6. Okay, it's literally the 6 bytes. It's literally the 6 bytes. That's what you mean by as hex. Black White Cookie says, happy to be here. Thank you so much for tuning in. And first time chat from Black White Cookie. How pog. We're just going to print out each byte. Did I really use char? Oh, man. So we're going to have... This is a mess, I know. So we're going to print the MAC address, which is a bunch of things. Sure, it doesn't matter. Is any of that gonna work? Okay, that does work. I'm not insane. Oh, I didn't do this. Hold on. Rebuild. All right, we're coming upon the end of the stream. Hopefully we get this MAC address out of here. Make sure to blaze it, Mafk. What do we got? Da, 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 da. Oh shit, is that right? Wait a second. 52, 54, 98, 76, 54, 32. Bog champ. We got the MAC address. We got the MAC address. We got the MAC address. I'm an idiot. Our network stack is complete. We've done it. We're done. We can now... We have a browser now. Oh, shit. In case you don't know, I'm being facetious, and we have basically done the equivalent of add 2 numbers together. Oh, Pog Champ. Oh, yeah. We got the Pog in chat by Sonaris. That's so beautiful. Yeah, ARP shouldn't be too difficult. Nope, don't do that. Oh my god, we did it. Okay. We're gonna commit this is what we're gonna do, because this is a mess, right? So we're just gonna start committing things. Did that say reuse merge? What did that even say? I'm kind of confused. I just saw a quick pop-up here, and I feel like it said something. Why is git commit not running? It's taken so long. Yeah, I don't think it... I think we're going to be doing pretty good. ARP is not going to be too difficult, but IP... Yeah, IP is basically packetization, isn't it? As far as I know. Ask the IP layer to create a packet, yes, of type blah, of size blah. The IP layer asks the Ethernet layer to create a packet of type blah, of length blah, whose target is blah. Ethernet layer creates a packet of size 342 bytes, writes in the first 14 bytes the Ethernet header, including the source address, MAC address, the destination address, translated from the IP address, and sends it back to the IP layer. Because the IP layer then writes the header after the Ethernet header. And then UDP adds its header, and then the DHCP has to do its checksum, and the UDP, excuse me, the DHCP just has the data. And then, yeah, okay. IP and TCP are the complicated ones, the rest are easy. Pretty much. Yeah. TCP is definitely ultra complicated, but I feel like, and yeah, IP is definitely up there because of all the address shenanigans and how it's interlinked with the layers above and below it. This didn't work. My Emacs is broken. Well, I don't think I'm willing to not use maggot for all of this nonsense, so can we restart, and does it work now? Does Emacs even open? Emacs doesn't even open, so that's an interesting one. I still can't believe we got the MAC address. That's Pog. Okay, chat, you're gonna have to go away a little bit. Sorry about this. Okay. Hey, look, you get to see my stupid little box. Streama 2022 LensorOS Control-X-G. Okay, I'll get chat back up and running for the end. I can't leave you guys hanging with this white box. Emacs packages, TTV image mode. Is there a load file shortcut? I don't think there is. There we go. ERC fill mode, why? Oh, it's so bad. I'm sorry. Where's the bottom? Alex RQ 1311, thank you so much for the follow. Okay, it's not tall enough now. It's not tall enough still. Okay, Pog. There's no white lines, right? First time chat. Hadouken! Bananenberger 69. Hey, Pog 69. What's up, everybody? Thank you so much for tuning in. I appreciate it. Especially that first time chat from Hadouken. Okay, so first we have stage changes already, just to do. To do, we should be using GNU Pact, since it's a thing. Instead, we are using attribute packed, which is not as portable and much, much uglier. Coolness. And what else do we have going on now? So what have we actually changed? I don't know if I want to change those scripts yet. So in system, we have new system device numbers. So maybe let's try and do the system device part first. And then we'll do the PCI enumeration, and then we'll, yeah. Hadouken, thank you so much for the follow. We are up to 390, which is absolutely insane. 390 followers on Twitch. I cannot believe it. This community is growing to such lengths, such proportions that it's blowing my mind. Check out the link in the About section of Twitch to go to the Discord, and from here you can get links to my YouTube and all sorts of things, GitHub, Codeberg, etc. Anyway, there's announcements every time I go live. You can ask to join the notifs group and be pinged on your mobile device every time I go live. So you'll never miss another one. Won't that be beautiful? And there's also tons of stuff, i.e. linguistics and code review and help and just off topic. You want to talk about memes? You want to talk about anything? Put it in off topic. But yeah, join the Discord. There's announcements. I ask about what I want to do on stream and what I should do. I take user input, do polls, do things. Be sure to check it out. Hadouken says, by the way, if I'm saying your name in an offensive or wrong way, just tell me. But I have fun saying names. Hadouken says, hard to find people who does not do web or game dev and not Rust. Oh God, just keep me away from Rust. Please. So I'm just going to do kernel add E1000 system device. Hadouken says perfect. Yeah, that's awesome. That's awesome. Because, listen, if you want to use Rust, the viewer, you, right? That's not really that big of a deal to me. Because it doesn't affect me, right? You're not forcing it on me. However, in my own projects, I will never use Rust. I've tried it multiple times. I gave it a chance. It's just not for me. I can't write effective software in it. I think if I learned in Rust, it would be different, or if I learned in Python or even like some higher level language, I might be able to do better with Rust, but it's just, I can't wrap my mind around it. And then they just make up names for things, and then they have syntax that's questionable. It's a mess. PCI. Detect OX100E progif. No, device ID. Intel E1000 network controller. Sure. Also in this commit, alter the behavior when an unknown progif is encountered. We should also do this for the unknown device ID subclass, etc. For better debug output. For better debug output, sure. Okay, so as far as PCI enumeration, We shouldn't even need bar type or anything like that. PCI enumeration. We should be able to effectively just add this. System create device, blah, blah, blah. Oh yeah, and none of this will work because we're still looping over things instead of indices. Probably should have done that first, but oh well. We still may be able to rebase, but that'd kind of be messy. Oh, Giathorpe. Oh, Glethorpe. Thank you so much for the follow. Glethorpe. That's a funky name you got there, I'm not gonna lie. Glethorpe? PCI. Create system device when E1000 is detected. Sure. Yeah, I would kind of really like to rebase these onto this commit, but I don't know if that's necessarily going to work due to it being later in the history. Beautiful stuff. Kernel, fix iterator invalidation, fix problem with system device iterator invalidation. Okay, stage 1. Sure. Basically, because we are appending to a container as we are looping over it, we need to ensure iterators don't get invalidated. To do this, we recalculate the iterator every iteration of the loop using an index, which means iterators stay yeah, whatever. I don't need to which means. So we're appending to a container as we were looping over it. I'm pretty sure we were only getting away with this due to the device's vector not growing large enough to resize in one of these loops. With the addition of the E1000 device, however, this has apparently changed. I think that's fine. Let's throw IPv6 into the ring. 128-bit baby. So this fixes iterator invalidation, sure. And there's no way I can like rebase. Yeah, it wouldn't really make sense to rebase earlier commits onto a later commit. I would have had to, I don't even know, make a new branch and then rebase these local unmerged commits onto that branch and then merge that branch into this one, but I don't need to do that. Okay. And I feel like maybe this should be optional. I guess it's a QEMU specific thing. I don't know. It doesn't really matter if it's optional or not. Who cares if the hardware has it installed? We will be fine. Uh-huh. CMake is kind of a meta. Actually, run QEMU with network card installed. I do have to fix these bits either way. Okay. This is going to be kind of random, I'll admit. These changes, but they're fine. It's fine. Everything's fine. Okay, then I didn't add the network thing. So instead of net none, we would now like that thing. Okie doke. I'm forgetting the PowerShell one now. Okie doke. Sound hardware PC speak. So I had to replace that one with the Windows one D sound. Okay. Don't do that. And then we need this NIC installed at the end. And there's the PowerShell version done. Scripts update run hda.star. Remove now deprecated sound hardware PC speak option. Replace with new audio dev plus machine. Yeah, audio dev. Replace with new audio dev option. Beautiful. Deepronova. Well, these names are good. Deepronova, thank you so much for the follow. I appreciate it. Run QEMU with E1000 network card installed. Update build a directory from kernel bin to just bin. Beautiful. We'll have PCI bar type. helper to get bar type, base address register type. Beautiful. And now we just have the new files and then the actual usage of them in case stage 1. And the CMake. Oops. Basic U1000 driver. Woohoo! We did it. We got the MAC address, baby. Woohoo! Beautiful stuff. With those 9 commits, we have now done it. Did I close? Here it is. I have so much stuff open. Oh my god. Okay, I don't need this anymore. We got this. We figured out what the MAC address is. Network stack. Pop that bad boy in here somewhere. And then this is here. Whew. So now we just need to actually use these descriptors and initialize a receive or a transmit. And then we can actually have our Ethernet layer complete. Probably need an Ethernet header. I see, that's probably what this RxDesk entails. It allows it to build the header. We can enable interrupts. But for the you should set the T. So this does enable PSP, shift, cold shift, and riddle C. But this says this one actually does different things. In the case, it will not be sent. In the case of I-217 and 82577LM, packets will not be sent if the T-kernel is not configured using the following bits. Okay. But yeah, there's still some more to do, obviously. Once we initialize both of these, then we'll have to actually figure out how to, you know, fire and receive something, send something. Well, we're getting there, we're getting there. This is just setting up the NIC, I think. I'm pretty sure we'll have to set Ethernet headers manually. Is that true? I didn't know if this NIC actually handled the Ethernet header. I don't have great knowledge of how this stuff works. Molly the man says, yo, I'm back. Yo! How's it going, Molly? We actually can read the MAC address now. So yeah, we're like halfway through. So it says, well, no, it can't. The ether header also contains, e.g., the destination address. Yes. Which we have to tell it. I see. I mean, we have the data length. So we can kind of just send it generic things. It doesn't actually know how to handle it. That makes sense. This is very confusing. So instead of detecting system devices, they're trying to like probe for them. This is weird. This is what we're doing though. Transmission control register with value. Also, you know, I would have read from the manual So it looks like maybe we can get a manual here for the 82577. C827. L210 series. I'm looking for like the 82 something. I don't even see it here. It's a mess. And I don't see it here either. Looks like the former manual was moved here. Ah, yes. Classic. But yeah, I would have read from the manual, but I can't find it. Molly the Man says, what is the MAC address? MAC in this case stands for Media Access Control. Each network interface card has a unique MAC address that can be used to identify it on the local network. Pretty much. Molly the Man says, thank you. I tried looking for the manual, I couldn't find it. Yeah, I couldn't either. I tried looking before the stream. It's okay. We'll find something eventually. Luckily, we have some documentation, not none. But yeah, it looks like this is a good stopping point. I have a million things open. Be sure to check out the OS on Codeberg or GitHub if that's your preference, but I prefer Codeberg. And, build it yourself. We're at 1,350 commits now. It's beautiful. It's over a year old. And we can now get the MAC address from an E1000 network interface card installed on the PCI bus of an x86-64 machine. How about that? We are starting up this OS. Finds the OVMF firmware, runs the UEFI shell, runs the startup script, runs the LensorOS bootloader, the LensorOS kernel, and finally we get to the LensorOS user space where we can type things, and hopefully Zeish still works. Look at us, Zeish still works. We can echo through Zeish. How about that? So yeah, we did that. Thank you everybody so much for watching. I don't have very much left. Be sure to check out the links down below. If you have not already, the About section contains a link to the Discord, and in the Discord there's announcements every time I go live. You can get a link to my YouTube as well as asking for the notice roll to get pinged every time I go live. Ooh. On the YouTube, there are VODs of every single stream I've ever done, so be sure to check that out there if you like that. Top Clean, thank you so much for the follow, I appreciate it. Straight says, not sure how familiar you are with how networking works in general, but if you want, we can get in VC or something next stream, and I can explain more or less what we need to do to get a functioning network stack if you're interested. Eyes. Ooh, I am interested. I am very interested. Also, I realized I forgot to do TTV image mode. But yeah, I'm definitely very interested in that. I was thinking about trying to get hardware, like try and set up some device files in the VFS, if that makes sense. For some recognized devices that we want to be usable through the VFS, if that makes any sense. But I think what that would entail is writing device drivers for them, which we already have some. So for example, the port controller, we have these AHCI ports, and we have controllers for them, but we don't actually have any way to interface with these from user space, which you could say is a good thing, because you can't like overwrite the master boot record on your disk from user space, right? That's probably something important. However, if the AHCI port doesn't have any GPT on it, doesn't have any file system on it, I think it would make sense to expose this HCI port to user space. That way you can read and write from it directly, just the device itself. And why I thought of that when I did is because we're also going to need sockets as a device driver. And the socket is going to have to be a device driver, a storage device driver, that is built on top of the network device driver that we don't even have yet. If that makes sense, because when we open and close a socket, we're going to have to open and close the connection that the socket, it's going to be a lot. It's going to be a lot. I think we can do it though. Overall, I don't have much to say anymore. I'm winding down. If you would like to say anything, be sure to get it in now. I would like to shout out Middle Cloud for the most recent donation to this channel. Middle Cloud is actually the twice most recent donator, so the person that's donated twice most recently. That would be Middle Cloud. Shout out to them. We appreciate it. Because of them, I can justify doing this more often and not worry about wasting my time. Not that it's a waste to hang out with you beautiful people in chat. Just that it's hard to justify when you're like, I could go make money or I could go sit at home and do nothing. Right? One of those is a little more motivating, I'd say. But yeah, thank you everybody so much for watching. I appreciate it. Suraid, Molly the Man, Hadouken we had earlier. I can't even remember. We had so many follows today. It was beautiful. Be sure to check out the YouTube. Check out everything. Sonaris says, thanks for streaming. It was fun catching you live. Thanks, Sonaris. That's right. You caught the first compiler video. Now you're in one. Whoa. Thank you everybody so much. I will, I've got nothing left, so be sure to check out all the links. Check out the Discord. You can get announcements every time I go live. Check out the Codeberg for the OS and my text editor, my GitHub for the compiler, which now has references. In case you didn't know, Intercept now has references. Oh. But yeah, be sure to stay tuned. We are working on all sorts of fun things around here, so click that follow, click that subscribe, tell your friends about me, and yeah, that's all I can think of. I would like to thank you profusely for watching. I hope you enjoyed, and if you got anything out of it, let me know down in the comments. Be sure to have any... I'll be sure to answer any questions down in the comments as well, so pop anything you're wondering down in there. Check out the description for all the links you need. I'll link to the resources I used in today's stream, as well as the usual source code, donate links, and such. Thank you, everybody, so much for watching. I have no idea what to do or say, so I will leave you with this. It was silence. Did you get it? It was silence. Bye, everybody.